Okay, hello everyone. Hope you guys are still doing well. Now today is actually going to be our very last video of the semester, and we're going to keep talking about how we can graph rational functions. As we saw the past couple of times, these can be very challenging to graph because of so many key features, and then sometimes we have to even pick new points to see what the graph looks like. So our new key feature today is called a slant asymptote or oblique asymptote. Now, as opposed to horizontal or vertical asymptote, slant asymptotes will, just like the way it sounds, it will be diagonal. Now, I do actually think that this is not as difficult as it might seem, as we'll see later. But the two questions are, when will a function have a slant asymptote? So all the ones that we worked with up to this point have not had slant asymptotes. So when are we going to have them? And the other question is, how do we find it? Okay, so let's answer the first question first. So when will a rational function have a slant asymptote? When the degree of the numerator is exactly one bigger than degree of denominator. Okay, so when we talked about horizontal asymptotes, we looked at their degrees. So if the degree of the numerator is bigger by any number, bigger by 2, bigger by 3, then there is no horizontal asymptote. If the degree of the denominator is bigger by any amount, then we know it's going to be y equals 0. And if the degrees are the same, then we take the leading coefficients and then we divide them. Okay, so slant asymptote happens when the degree of the numerator is bigger, and not just bigger by any number, but bigger by exactly 1. Okay, so if it's exactly 1 bigger, then we're going to have a slant asymptote. And of course, since it's bigger in the numerator, then there is no horizontal asymptote. Okay, so now that we know when there is going to be a slant asymptote, the next question is, how do we find it? And this is actually an idea that we learned back in the first semester when we did polynomials, and we're going to use long division. Okay, now I know this was an idea that many of you did not like because of, it was a long process and it was kind of tedious. But the good news is in this case is that we don't actually have to do the whole process. We just need to do the first couple of steps of long division. And once again, that'll be more clear once we do some examples, which we'll do right here. So find the slant asymptote of the following rational functions. Well, first of all, let's look at the degree. The degree on top is 2. Degree on the bottom is 1. So the degree on top is exactly 1 bigger. So then we know we're going to have a slant asymptote. And then let's look at how do we find it? So let's go ahead and use long division. So we're going to divide x squared minus x minus 12. Divide that by x plus 10. Okay, and just as a refresher in case you forgot, first you want to see how many times can x, let me highlight this, can x go into x squared. In other words, what multiplied by this x will give me x squared? Well, the answer will be x, right? Because x times x will be x squared. So let's go ahead and multiply. X times x, I get x squared. And then x times 10 will be plus 10x. And then remember, now we're going to subtract. This is often a very easy place to make a mistake. These x squares will cancel out. And then what happens if I do this x minus the 10x? Well, it will be negative x minus 10x. So that's negative 11x, means a different color. And then let's drop down this minus 12. And then let's divide one more time. So what times x will give me negative 11x? Well, that will be minus 11. And that's actually all you need to do. You don't actually have to keep multiplying and keep going to find what the remainder is. That we don't really care about. All we care about is this right here. So it's going to be x minus 11. So that's going to be our slant asymptote. It's going to be a diagonal line. Y is equal to x minus 11. Okay, so this, we're not going to graph it right now. We'll do some graphing later on, but that's going to be our slant asymptote. And then let's also look at the other asymptotes. So for horizontal asymptote, we already know the degree on top is bigger by 1, which means that there's going to be no horizontal asymptote. How about vertical asymptote? That's still the same as before. You're going to set the denominator equal to 0. So x plus 10 equals 0. So then our vertical asymptote is x equals negative 10. Okay, let's do one more example of finding asymptotes. So here again, slant asymptote, the degree on top is 2, on the bottom is 1. So that's 1 bigger, which means we're going to have a slant asymptote once again. And we're going to use long division. So that's 2x squared minus x minus 3. Okay, once again, let's go ahead and see what times x will give me 2x squared. And the answer to that will be 2x. Okay, and let's multiply. 2x times x is 2x squared. 2x times minus 2 minus 4x. And then subtract these. 2x squared cancel out. And then we have this minus x minus negative 4x. I think that's going to be positive 3x because I'm doing negative 1 minus negative 4 or negative 1 plus 4, which is positive 3. And then drop down the minus 3. And then do it one more time. What times x will be 3x? That's just going to be plus 3. And again, you don't have to multiply again to find your remainder because we don't care about that. All we care about is right there, y equals 2x plus 3. So there is my slant asymptote. And then again, just for some practice, let's find the other asymptotes as well. How about horizontal asymptote? Once again, because the degree on top is bigger, there's going to be no horizontal asymptote. Vertical asymptote, we set the bottom equal to 0. X minus 2 equals 0. So we get x equals 2. Okay. So that is going to be, or that's our last key feature. And then let's see how we can incorporate that into graphing as well. Okay, and then before we do the graphing, again, I just want to kind of re-emphasize what I mentioned in the previous videos. I'm not expecting each of you to master this completely, especially given how little time we have. Again, the goal is to get you guys familiar with these ideas of with asymptotes, and especially slant asymptote. You're actually going to see this when you take pre-calculus next year, which most of you are taking. This will come up again so that when you see it next year, it won't be completely new to you guys. Okay, so let's go to the graphing. Once again, let's start with all the key features. I'm going to start with, again, as always, the intercepts. So x-intercept. And then I don't have the chart from last time up here, but hopefully by now we know what those are. If not, you can always look back at your previous notes. So x-intercept, you'll need to set your numerator equal to 0. So if I do x squared equals 0, and I need to take the square root of both sides, I get x is equal to plus or minus 0, but that's just still 0. So then my x-intercept is 0, 0, right at the origin. How about my y-intercept? And I do that by setting x equals 0. And then let's solve for y. So I get y is equal to 0 squared over 0 minus 1, which again is 0. So 0, 0. That's actually already graphed at the origin. And then next, vertical asymptote. Denominator equal to 0. And I get x equals 1. So let's go ahead and put that in. There's my vertical asymptote. And let me actually graph that as well. X equals 1. Keep going. Horizontal asymptote. Okay, degree on top is 2. Degree on the bottom is 1. So it's bigger on top. So that means we don't have any horizontal asymptotes. And then finally, slant asymptote or oblique asymptote. You might hear both terms pretty frequently. Oblique asymptote is the same as slant asymptote. Again, looking back up here, that happens when the degree on top is exactly 1 bigger, which is again what we have because it's 2 is 1 bigger than 1. So let's go ahead and find that as well. I'll do it down here. Let's do that by using long division. So I'm doing x squared divided by x minus 1. Yep. And then let's go ahead and do the division. So what times x will give me x squared? Well, that's going to be x. And then let's multiply x times x squared. X times minus 1 is minus x. And by the way, I should have putting some missing terms up here because this is x squared, so there's no x term, so I shouldn't, or I would need to add a plus 0x, and then plus 0 because there's no linear term or there's no constant either. Now you can subtract, x squares cancel out. This is 0x minus negative x or positive x. And then again, we need to divide it one more time. So what times x will give me x? Well, that's going to be plus 1. And again, we can just stop here because all we need is these two terms. So then let's go ahead and write in our slant asymptote or oblique asymptote, y equals x plus 1. Okay, now how do we graph this? Well, this is a line, right? So y equals mx plus b form. So hopefully we still remember how to graph that. We'll start with the y-intercept, which is plus 1. So that's going to be right over here. And again, this is an asymptote, so I want to make sure I'm using a different color than my actual graph. So here for the asymptotes, I'm using green. And then the slope here is 1. So I'll go up 1 over, rise over 1. So up 1 over 1, up 1 over 1. Or I can go this way as well. And then again, since this is an asymptote, let me draw this using, or connect these using a dotted line. So something like that. There we go. Okay, so there's my oblique asymptote. And again, once you have all these key features, your graph should be much easier to graph. So I see that I have a point right in here. And then again, because of the asymptotes, I know my graph has to go towards them. But the only difference here being that instead of the graph going towards a horizontal asymptote, it's going to go towards the slant asymptote. Okay, so there's my graph there. But again, we know there's going to be a graph in this part of the plane as well. And how do we know what the graph of that looks like? Well, we need to pick a point again. So here, let me use an x value that's in that region. So here I'm going to pick x equals 2, a nice easy point to pick. And then what's my y? Let's go ahead and plug it in. Y is equal to 2 squared over 2 minus 1, 4 over 1, or 4. So when x is 2, y is 4. And let's go ahead and graph that as well. So when x is 2, y is 1, 2, 3, 4 right up here. So now that I have that point, I can use that to draw in the rest of my graph, which we know is going to go towards my asymptote. Okay, so there it is. And then we can actually look at the domain and range as well. Let's look at domain first. So domain is going to be, it looks like all real number, except that x cannot equal 1. And then we can actually skip the range. Finding the range will actually be a bit more challenging because we don't know we don't know exactly where the points are. So this we can actually skip for our sake. But yeah, there it is. So the ideas are all the same, except with the introduction of a new key feature, and that's slant asymptote or oblique asymptote. Okay, I think there's going to be 3 more graphs. I'll do one more with you guys as or in this video, and then I'll let you guys try the last 2 on your own. Okay, so x squared minus 4 over x plus 1. Once again, we see that there's not going to be a horizontal asymptote because the degree on top is bigger. But we are going to have x-intercept by setting the numerator equal to 0, and then by factoring x plus 2, x minus 2. So then we get x equals 2 and negative 2. So we actually have 2 x-intercepts, and make sure you graph both of those, there and there. Y-intercept, as always, set your x equal to 0, and then we get y is equal to 0 squared minus 4 over 0 plus 1. and that will turn out to be -4. And then make sure you graph that as well. There it is. Okay, and then how about my vertical asymptote? Set the denominator equal to 0, and then I get x equals -1. There we go, and let's go ahead and graph that as well. Okay, and then the only thing we're missing is going to be oblique asymptote. Once again, how do I know there is one? Because the degree on top is exactly 1 bigger than the bottom. How do I find it? Well, that's going to be long division, so x squared minus 4. And again, make sure you're putting any missing terms. So here, there is no x. It's x squared, but then I'm going to put in a plus 0x minus 4 because that's going to make her division step much easier. So here we go. What times x will be x squared? That's just going to be x again. So I get x squared plus x. Subtract. X squares cancel out. This will be 0x minus x. So that's -1x or -x minus 4. And then what times x will be -x? That will be -1. And then again, we can just stop there. Our oblique asymptote is y equals x minus 1. And then again, let's go ahead and graph that. So here the y-intercept is -1, which is right down here. My slope, again, it's rise over 1. So again, it's +1. So up 1 over 1, up 1 over 1. Or I can go this way. And then let's go ahead and graph that with a dotted line as well. Here we go. Going this way. Okay, so that's all of our key features. And this time, it's going to be actually pretty easy to graph because I don't think we need any additional points because I see that we have points here. So that's going to go towards the asymptote. And then we have point up there, and then that's going to go toward the asymptote as well. And then similarly, we have a point on this side already, so I don't need to pick an additional point. So I can just go ahead and draw my graph using the asymptotes. Let me actually make this a bit longer. There we go. Okay, so again, let's go ahead and find the domain. We don't have to worry about the range. Domain, all real numbers except x cannot be -1, it looks like, because that's my vertical asymptote. And then range, in this case, if you're curious, is actually going to be all real numbers because this part of the graph right here goes all the way down to -infinity and goes all the way up to +infinity. And then same thing with this part of the graph as well. So range here, in this case, is all real numbers. But we don't really have to worry about that. Okay, so for the assignment, just these two questions. Again, these will both have oblique asymptotes. The rest of it is the same as before with the other asymptotes and the intercepts. Okay, so that's pretty much it, actually, with the entire year, actually. That was our last topic that I wanted to cover before the end of the year. So once again, do make sure you take notes and then try these last two problems for next week. And then, of course, let me know if you have any questions. Once again, it's perfectly fine if you're not following 100%, because again, the goal is to get you guys at least familiar with these topics of asymptotes, because again, most of you are taking pre-calculus next year, and these will all come back multiple times next year. Okay, thanks again for all of your hard work, and do let me know if you have any questions. But other than that, have a great weekend, and I'll see you guys next week.